All right, hello everybody. Just coming at you today with a quick video on aggregation. Okay, we'll call it section 3.5. Now, this isn't in your notes. I don't have any homework for you. I don't have any coding exercises for you with this one. Mainly, I just want to talk about this idea to help prime you for what we're going to be doing in our next project, okay, the Unit 3 project here. Okay, so not something you're going to need a ton of practice with, but just with the way our schedule works this year, we'll lay this out here so it hopefully makes life easier when we get back together and get into the next lab. All right, so aggregation, what is it? I'm going to say it occurs when an instance variable of a class is another object. Okay, so when one class or one object is holding as a variable another object. So for example, in a second we'll show you a coding example where I'm talking about the cylinder class. Okay, now cylinders, the geometric figure, have a circle in them. Okay, so we're going to have a cylinder object that also holds on to a circle object as an instance variable. Okay, we're going to refer to this as a has-a relationship. Okay, so the cylinder is going to have or has a circle object. And the reason aggregation is good, the reason we'll use it, is it helps us reuse code, okay, helps us avoid repeated code, and also makes programs simpler to write. All right, when you're writing classes with aggregation, there's kind of two different, the same security issues to watch for. We'll show you what we mean when we get into the example more specifically. Basically, it's a lot of the same issues we ran into in 3.4, where we were copying objects. But I'm going to say when you copy an object, you want to copy an object's attributes as in its variable values, not its reference, okay, not its reference value. And also same idea, you want to return an object's attributes, not its reference. We'll show you what we mean by that in a second here. All right, so let's jump into the 3.5 coding demonstration. And what I have here is a set of classes that don't utilize aggregation, and we'll show you how aggregation can simplify things, can make life easier for me. Okay, so I have four classes that, as of now, aren't related to each other. We've got a main method, a cylinder class, which is going to allow me to construct a cylinder object, get its volume, get its surface area. Again, a cylinder, really when it comes down to it, is a circle at its base, which is made up, a circle, the only variable you need for that is a radius and a height. And then same thing with a cone object, which will have a radius for the circular base, a height, constructor along with the get volume and get surface area methods. Okay, right now I'm not utilizing the circle class, but I've got my main method here where I'm going to create two cylinders, get their volume, get their surface area, create a cone, get its volume, get its surface area. I can compile this, I can run it, and I can get this information here. Like I said, this program works, it just doesn't utilize aggregation yet. Okay, if you want to review some geometry formulas, feel free to hit pause on this video. Take a closer look at these classes. We're going to start making them better though. Okay, so when we jump into the cylinder class, the thing to notice is there are some kind of ugly chunks of code within my get volume and get surface area methods. Okay, this right here is just a calculation of a circle's area. And right here that's repeated, I'm finding the area again for surface area. And I'm also finding the circumference, okay, pi times 2 times radius, okay, pi r squared is essentially what's happening here. And then notice the cone class also reuses this, pi times radius squared for the volume, and then pi times 2 times r circumference for the surface area, along with pi times radius squared for the area again here. Okay, so between these two classes, they've got repeated code, and they're more complicated than they need to be. That's where I'm going to utilize aggregation. I'm going to bring this circle class into play. basically instead of just holding on to radius and a height for both the cylinder and the cone, what I'm going to do is I'm going to give them a circle object to hold on to. And then I can utilize these circle methods, okay, to get the area, get the circumference, and simplify my code here. Okay, so let's go ahead and do that. The cylinder is still going to have a height, but I want to get rid of this radius here. I suppose these should be private instance variables. Whoops. So we'll say private circle, and I'm just going to say lowercase circle. So in other words, this cylinder object keeps track of a circle as a variable along with the height. Okay, the height is an int, but the circle is a circle object, okay, as in the circle class. Okay, that's going to change what I have to do with my constructor. So now my constructor, rather than passing in a int for the radius, we're going to pass in a circle object. We'll just call that C, to set the value of this circle variable. Now, as far as security goes, what I don't want to do is I don't want to just say circle equals C. Okay, circle again is a circle object. By assigning it to C, what I'm doing is I have another circle object and I'm copying its reference. In other words, I'm pointing two reference variables, this circle instance variable and the parameter I'm passing in to the same circle object. Now in certain cases that might be okay if I just pass the circle into the constructor, but in other cases if I have a different circle floating around, I don't want to make a bad copy like that. I want to have two separate circle objects. Okay, so what I'm doing instead is I'm going to say that this circle instance variable is equal to a new circle object. And what did it take to create a circle? Well, we had to pass in the radius, okay, for my circle constructor. So what I need to get then is the radius from this circle parameter C. So what I'll do is C dot, in my circle class I had a method to get the radius. So we'll say C dot get radius. Okay, again, what that's going to do is it's going to create a new circle object to store as this circle instance variable, rather than just copying the reference of this parameter. Okay, that way I have two separate circles and they aren't going to interfere with each other. Okay, moving along then, like we said, the big thing we can do here is simplify this get volume and get surface area method. Rather than having this calculation for the area of a circle, what we'll do is we'll just say circle, as in the circle object we're storing here, dot get area. And then what that's going to do is use the get area method from our circle class, which already had that calculation, so we're not repeating that code over and over again. And it's going to call it on this circle instance variable that each cylinder object is going to hold on to. Okay, we can do the exact same thing with the get surface area method. We'll lose the pi times 2 times radius and just say circle dot get circumference. If I spell everything here, it's going to be a miracle. And then same thing, we've got a repeat of the circle's area here, pi times r squared. So again, we'll lose that and say circle dot get area. Okay, now if I want to test that code, I'm going to have to change the way my constructors are working here. Okay, so here I still want to create a circle with a radius of 3 and a height of 7. But in my constructor, I can no longer pass in a int for a radius. I actually have to pass a circle object. Okay, so there's two ways we can do that. We can construct the circle first. We can say circle 1 equals new circle object, where again with that circle constructor we're just passing in a radius. So if I want my radius to be 3, we'll just pass in the 3. And then within the cylinder constructor, I can pass in circle 1. Okay, or what I can do is rather than creating that circle object ahead of time, I can just pass it directly into my constructor of the cylinder object. So we can say new circle with a radius of 2. And now the difference here is that in the first case, when I created that object ahead of time, we actually stored that circle object in a reference, whereas here it's just going to be passed as a parameter stored in cylinder 2's circle reference. But then once that constructor is over, this parameter will cease to exist and we have no way of actually accessing that. So I guess in the first case we have 2 different circle objects with the same radius. Now they aren't related to each other. When I call methods for one, it's not going to affect the other. And in the second case, the end result is only going to be 1 circle object. Okay, compile this. If that's the only typo I got, we're good. Compile again. Ooh, there we go. Run. And basically our program is going to work the same. It's going to give us the same volume and surface area for cylinder 1 and cylinder 2. Now I can do the exact same thing with the cone class. Trying to decide. Tell you what, why don't we leave that as a exercise for you? This video is getting a little longer than I want it to be. Why don't you do the same thing with the cone class? Lose this radius instance variable and replace it with a circle object. Now you're going to have to update your constructor, and that's going to allow you to lose these kind of ugly calculations in the get volume and the get surface area method. Okay, here is our circumference. Here's our area of the circle. Okay, there's a calculation for slant height here, a local variable that makes this calculation a little bit easier here as well. Okay, but yeah, let's leave that up to you. That's your homework or exercise for this lesson. Why don't you do the same thing with the cone class? Utilize aggregation and the circle class to make this class a little simpler. All right, there you go. That is aggregation. Like we said, fix that cone class up. Practice using aggregation there. If you have questions, I suppose email me. Just basically you want to be able to get the same volume and surface area out as it does already. Okay, just making life a little easier. Okay, and that's going to help you get ready for the lab we get into when we see you next. All right, we'll see you guys later. Yeah, let me know if you have any issues.